Hey, what's up, guys? Long time no upload. I've been really busy with other things, but I'm trying to put together a video today. I got my plants planted yesterday and I set everything on autopilot. I just got up today and everything is still alive to my surprise. So I'm going to show you that in just a bit and go over some of the things that I've come across that it seems like the experts and um, intermediate guys just seem to gloss over. But uh, yeah, things like that are really hard to find any info on, but kind of, no brainer stuff to people who've been doing it for any amount of time. So I apologize for that glare in the forward facing camera. It's still broken. So what we have here, I've got everything labeled on the sides. And I'm running it on 4 15-minute cycles a day, the pump that is. And currently I've got the fans and the lights coming on at 7 a.m. and turning off at 8, something like that. No, whatever the schedule is, it's 14 hours of light. And I've got my upper lights on. This timer and fan, upper lights and fan, or lower lights and fan on this one. I did find that you can basically get these timers with 2 outlets on them at Harbor Freight for like $7. And if you don't want to print your own housing for them and do all the wiring and all that stuff, of course they don't come with these, clips. But, it's easy and cheap. Now, what I'm going to do for the pump and possibly the lights is, I was thinking about it and got the pump blue, and I wanted some kind of redundancy in the timers because these are cheap Chinese timers and I don't trust them very much. So I talked with an electrical engineer buddy of mine, and he sent me a diagram how to connect a couple of them in parallel. So I'm going to make another housing for 2 of them in parallel, and that way for the pump, if one of the timers dies, the other one will just take over. In the meantime, I can just come in here and hit that button until that light comes on and wait to hear the water running, and I'll know I'm good to go on that. I think that by far the biggest turnoff and obstacle for beginners is pH and EC or ppm. And it was something that I dragged my feet on because I didn't have a lot of money for a fancy pH meter and EC and all that stuff. So I went as cheap as possible. And that was this meter. As cheap as possible for a combo meter. And this one was off of eBay. This one came with no buffer solution, so there was no way to calibrate the pH or the EC. But it was like $17. So I was like, well, what am I going to do? Am I going to just assume that it's calibrated? I don't think so. So then I found this combo on Amazon. It was like $10. Now I bought it because it had the buffer solutions for pH. And I figured, well, since that one's dirt cheap and it didn't come with any buffer solution, can I trust it, even if I calibrate it? Well, if I get this combo, at least I'll have something to compare it to, and hopefully, well, at least one of them will work, and I'll get a good idea of which one doesn't work. So that's why I got the other set. I finally got around to calibrating both of them yesterday. I mixed up a batch of all three of those, and I saved it in these jars. Somebody will probably tell me 5 years from now, when people start watching this, that you can't save that, it goes bad. Well, thank you in far advance. So anyway, I'm gonna keep those solutions and try to see if they're any good within, a month or so, next time I go to calibrate. I do have that other set, and you can get more of that stuff on Amazon. It's not very expensive. Now, fortunately, when I bought that, I didn't think that the ranges were the same, but calibration for the red meter requires these specific ones. Just by coincidence, there are different pH buffer solutions of different strengths. So that was fortunate. I was not expecting that. I was expecting to maybe get one that I could calibrate it with, and that was all I needed. I still don't have a way to calibrate EC. I'm not really all that worried about it. I'm much more concerned about the pH. Now, when I calibrated those meters, I don't think the yellow one calibrated very well. Oh, one more thing. I haven't done a ton of research on these meters, but for pH meters, they have looks like a little glass LED or something on the bottom of them. Well, that thing needs to stay moist in an electrolyte-rich solution, so I just picked some of that up. It's EK something. I think it's called EKC. So anyway, yeah, that keeps them from drying out and keeps, I want to say, electrolyte in that sensor to keep it working, and if it dries out, they won't work. I don't know if they completely die if they dry out. Both of these came dry, and I didn't figure out that they needed to be kept moist in that solution for several weeks. And then I figured it out, and I figured, well, let me get some of that solution and just store it in them for at least 24 hours before I calibrate them. So that's what I did. The red one seems to be working spot on. So just for kicks and giggles, we will go ahead and test the pH and EC with those meters to compare them. I've got some distilled water in there, and we're just going to use that to rinse it off. I hope you can see. Okay, good. That's right where I want it. My pH was it was very neutral. It was 7 something, and it needs to be a little bit lower than that. So I don't have any pH up and pH down. I put 10 drops of white vinegar in there, and it got it within the range I was looking for. Oh, yeah, EC. Now, this is some funky metric unit. You just divide that by 1,000 to give you your conventional EC, so 2.13. And I'm gonna bump this up a little bit later. I wanted to keep it kind of low. Everything I've read says brassicas like it, a little bit higher than, maybe as much as 3.2 maybe. I can't remember what I read, but I wanted to keep it kind of diluted for now. So I think this meter is working properly. Let's see the other one. Yeah, see? This one is not getting the same reading. Let's check the EC meter that came in that combo. Yeah. Crap. So, yeah, I don't think... that's the thing about cheaping out on stuff. You pay for what you get. So, yeah, that combined with, the expense of something like a Blue Lab or whatever, just starting out, yeah, you would have the assurance that you get accurate measurements, but do you want to spend all that money on something like that? I needed a hobby, so if it failed, I was willing to, well, I'm still willing to start over if everything dies, but you might not feel the same way. One more thing before I go. I was going to make a video on this, but I decided not to. I did not get favorable results, but I had this idea about taking hydrogel balls, like the things that you shoot out of gel blasters, Orbeez, those things, and I wanted to use them to make a self-watering valve, like a sensor that would open a valve and deliver water when it was needed, like when soil dried out or whatever medium you've got. And the idea to do that was I printed up several iterations of these. This is just nothing but infill, so it's permeable, and inside here would go the hydrogel balls. And the idea was that as they hydrated and expanded, they would shut off the flow to the water flow right there, and this would be on like a gravity feed system. So they would hydrate, expand, fill up that tube, and then press on the inlet and not allow water to go through the come out here out of this permeable membrane, I guess you'd call it. And I kept getting like really weird results. What would happen was I would go ahead and start by hydrating the hydrogel and water, and then figuring out the correct number to put in here that would close the valve. And this is just a little spacer that I printed out to drop down in there to give me the correct number of balls that went in there in order to close this once it was fully hydrated. What was happening was the soil would, I'd get it to that point, and then I'd put water behind it, and the balls would be stopping it from coming through here. And as the soil dried out, these balls shrank and allowed this to open up. And the theory was that the more balls you have, the quicker an actuator you're going to have as soon as they get wet. What I kept having happen was I'd come back like the next day and the reservoir would have completely dumped everything out, and it did not close the valve. And I did this many times, and I tried to catch it doing it to figure out what was going on. I never could catch it. And it was like, you know, Schrodinger's hydrogel balls in there. This was the first iteration. This is a cannibalized float valve with basically a piston that sits on hydrogel balls in there. So the idea is as they shrank, that would drop and open the valve. Never could seem to get that to work. I think it's because there wasn't enough airflow to let anything evaporate. But anyway, I got to wondering about it, you know, what was going on inside here, and I said, well, you know what? I read a paper on hydrogel actuators, actually. And there was something in there about, no. It was a YouTube video. I can't remember the name of the guy. I'll post it right here. But he just happened to post a video on hydrogel and what happens when you mix it with salt. And you mix it with salt, and the hydrogel can't absorb as much water, and it either pushes it out or it doesn't. It's not able to uptake. So I thought that maybe something like that was going on with this. So I got several jars, and during the process of setting it up, I said, wait a minute, what if pH also affects it? Because previously all my tests were in some like potting soil, and you know, no idea about the pH of that stuff or what kind of dissolved solids are in it or anything like that. So long story short, what I found was that pH greatly affects how the hydrogel uptakes, and anything above or below a neutral pH, and the hydrogel cannot absorb as much water, therefore it does not grow as big as it can in neutral water. So what was happening was, as these dried out, as this was sitting in the soil, as it dried out, the valve opened and the water came in, but as it filled up, it leached out a bunch of stuff from the soil, and the balls were not able to expand to their full capacity, therefore not shut the valve off. So if you were to do this, in a hydroponic system, you wouldn't have the same issues because everything's monitored and it's supposed to stay within a certain range. So I haven't totally given up on this idea yet, but I got real busy with everything else, and I did not have a working hydroponic unit at the time. So as I progress, my plan, I'll probably pick this back up in the spring when I do some hydroponics outside. Anyway, yeah, I thought that was kind of cool and worth mentioning. So more on that later, or if you want to pick it up, have at it. Just I'd appreciate it if you share your findings with me. All right, that's going to wrap it up for this one. Later.